Wow, welcome to this weird situation again. Okay, so we're going to look at things we can do with our CAS calculator now. So make sure it's turned on. So solve the equation, give your answer to two decimal places. Well, whenever you see two decimal places, you're probably not going to have to use exact values. It's asking you to use your calculator. What do we do here? Just simply go straight to our graphics calculator, type solve. Don't forget comma X. And it's giving you a couple of solutions. Okay, so one of them, if you think about the graph, one of them will be, to the left-hand side of the x-axis, to the y-axis. This one's to the other side, and you get this little triangle up here, and it happens a few times when you use your graphics calculator. And what it means is the calculator is telling you that it's had a guess. It's saying I might be wrong. So it's always best when you get an answer like that, just to give it a bit of a think. Okay, does that make sense? The fact that both of that's a minus 1.89, that's 1.89 makes me think it is correct, because one of them will be one side and one of them will be the other side. But that little triangle, give it a thought. Okay, here's a quite an extensive question here. So you're going to need to you probably need to stop this video a few times, rewind it to make sure you know what's going on. And don't forget, you've got access to this PowerPoint yourself, so you can go onto Google Classroom and actually just run the PowerPoint yourself. So fit a sine curve to these points. So what I thought I would do, I've actually drawn the points. So I just went onto Desmos and plotted these points. I'm thinking, okay, you've got to try and get some sort of sine curve here. So do you reckon it's going to do something like that? Something like that. So as a human, we should be able to visualize what's going on, as well as use technology to help us. So open up a new spreadsheet. So Control I, list and spreadsheet. I've called this one XS and YS. It doesn't really necessarily matter what you call it, as long as you know which one's which. Take care, because it doesn't go 1, 2, 3, 4, 5. It jumps to 6 there. So just take care when you're doing that. So tuck them all in. Now, sometimes depending on what your settings are, you might end up with a fraction here. So it might give it as a fraction. Don't worry if it's gives it in fraction form. But, if you want to have a play around with the settings to change it, again, that's fine for you to do that. Okay, then open up a calculator application. So Control I, calculator, and go menu, stats calculation, sinusoidal regression. And I think you're gonna have to scroll down, because you got 1, 2, 3, 4, and I don't think it shows C's. And when you have a look, see, we could have tried to do a quartic, tried to do a cubic, tried to do an exponential. So this is us giving the calculator a clue of what we want it to do. So we want it to try and draw a sine graph. So you hit that, and then it tells you to put your list in. So remember, I called mine XS and XY. YS, so whatever you call them. Now, when you do this, it's going to create a formula. I think it comes up as F1. So I think the first one, it comes up as F1, unless you've done, previously, and you might say F2, F3. So put it as F1, and you could probably just leave these things as they are. And you get this. So it's telling you, okay, I'm going to draw a graph. It's going to be in the form y equals a sine bx plus c plus d. These are my values of A, B, C, and D. And what it's done is it's automatically put the formula into a graph for you. So it's already put the formula into a graph. So all you have to do is go Control I, add a graph, and don't forget to press enter, because I was doing this and I was getting no graph, and I thought, just press enter, and then the graph appears. Do a bit of playing around with your window, because yours isn't going to look like this the first time you do it. So have a play around with your window to try and get it to look like this. And there are the points. So I kind of was right, wasn't I, with where the graph went. Now it's got to, if we go back to here's our values of A, B, C, and D, and it's put them in here. A, B, C, and D. A, B, C, and D. Now, it's kind of wrong, because really the equation of this graph is y equals 5 over 2 sine x. 2.5, 5 over 2. I don't think I'll have any arguments with you there. 0.981 is practically 1, isn't it? It's practically the number 1. So this is your calculator's had a go. It's I've drawn the graph, but really that's 1. So we just got 1x, so we don't need to put anything there. So it's just sine x plus 0.003. Now 0.003 is practically 0, isn't it? It's 3/1000ths. So we don't need to put plus anything. And then outside the bracket, we've got a plus and a minus, which we've got a minus 0.001. Again, that's practically 0, isn't it? That's 1/1000th. So if you were to write down the equation 2.5 sine 0.98x plus 0. You're going to lose some marks, aren't you? Because we can teach you how to use the calculator, but then your brain's got to take over and you've got to do some thinking. Okay? So you've got to do some thinking. That is really this. Weird, hey? Okay, general solutions. So here's y equals cos x, the curly bit, and there's y equals a quarter. And we can see there's a solution would be there, and another solution would be there. We also know that this graph goes on forever that way, and forever that way. So this goes on infinitely, doesn't it? So what we're going to do is we're going to look at the general solution. So it means it's not just one solution or two solutions or three solutions, but there's a formula that you can use which will give you all of the solutions. So forever. I know it sounds a bit weird. So if we find the answer, the solution between 0 and 2 pi, 0 and pi, we can see that there's where the solution is. Okay, so there's the graph cos x, that's the red one. Graph of a quarter, you can see that's 1. There's a quarter because that's a half, 3/4, 1/4. So the solution is there. So if we just work out cos to the -1 of a quarter, we get our first solution. Then if we add 2 pi, we get the next solution. And that means plus or minus, yeah? So we're adding plus or minus 2 pi. We keep getting the other solutions, and then we do it with 4 pi. Remember, because 2 pi is 1 all the way around, so 4 pi is around again, and we just keep going, and we just keep going. So plus or minus is taking us this one and this one, plus or minus that one and that one, that one and that one, that one and that one, and we just keep going on forever. So basically, there's a pattern you can just see. It's just plus 2 pi, plus 4 pi, and the next one will be plus 6 pi. So what we're doing here is we're creating a general equation. Okay, so just you might want to stop the video, have a little bit of think. What does this mean? Do you remember when we were doing the tan graphs, and to work out where the asymptotes were going to be and to work out where the intercepts were, we had this number k, and lots of people go, what does this k mean? So basically what the k was, it wasn't that k would start off with k being 0. That would probably be your first one. And then you do k equals 1, k equals 2, and if you go into the negative, you have k equals -1 and k equals -2. N here is the same as that. So you start off, if you have n equal to 0, that would be your first solution. N equal to 1 would be the other ones. And because it's plus or minus, each time you do it, you'd get 2 solutions. So n equals 1, n equals 2, n equals 3, n equals 4, n equals 5. And you don't need to worry about n, because n is a z number. It means it's going to be positive, doesn't it? It's always going to, because this here takes the plus or minus, takes care of it. So you just start off with n is 0, 1, 2, 3, 4. So we can, and there's other ones for tan, and there's other ones for sine. So basically, you've just got to know this. Obviously, if it's a tech-free, if it's tech-enabled, you've got your calculator and you've got your notes. If it's tech-free, you've got to know these. And they annoyingly, see this one here's got a plus and a minus. This one here we've got 2 for sine. So sines are paint, and I think n can be a negative number. So n can be a negative number. The z just means it's an integer value, yeah. So n can be a negative number. So getting your head around these is going to be quite tricky. It is going to be difficult. So do the questions, do the questions, do the questions, do the questions. 2 for sine. So find the general solution. So the general solution means the solution for the whole of the cos graph from -infinity to infinity. And this one here, the tan graph. So you've got to remember the rule. Okay, so 2n pi plus or minus cos to the minus 1 of whatever this is. So from exact values, half, that's a half, isn't it? So it's going to give us pi on 3. So yeah, I reckon we've got our answer there. We've got it. That's the general solution. But annoyingly, you're still going to have to do some work with that. They don't like it in that form. So what they've done is they've put it all over 3. So obviously that doesn't change. That just stays as pi. But that will become a 6 on it. So if you times it by 3, you're going to get a 6. There's a pi there. There's a pi there. So you take pi outside the bracket. So that form there is just a different way of writing that. And it's just notation. When you're doing the questions and you're looking at the answers in the back of the book, it's always going to be written in that sort of form, even though that is correct. Yeah, they like to have it in that way. Have a look at the next one. So we're going to take that root 3 down to the bottom, so it becomes 1 over root 3. It's 3x. Here it was just cos x. Here it's tan 3x. So now we're just going to use the rule. So for tan, it's n pi plus tan to the minus 1 of whatever that is. Then we are going to look that up in our exact value, and it becomes 1/6. So we don't forget we've still got a 3x there. Still got a 3x. So basically, we've done here what we did here, because we still got a 3x, still got a 3x, 3x. So I'm guessing that's going to become an 18. It is. So x becomes this. So here we're just taking that 6, making it all over. So we have to have a 6 there as well, because 6 divided by 6 is our 1n. Just the notation that they like to use. And of course, our calculator will do it for us, won't it? So there you go. You just do solve, and it does it for us. And probably this is the first time you've maybe used this function, so it'll come up with n1. Next time you do it, it'll come up with n2, then n3, then n4. Obviously, when you're writing your answer in your book, you don't write n1, you just write n. If you write n1, it's telling the person marking it, me, the examiners, you don't really know what you're doing. You're just copying what's written on the calculator. So make sure you don't write n1 or n2 or n3, you just write n. It's just the way your calculator does it. Section summary. So these are the things you've got to remember. Now, once you've done loads and loads of these questions, it will be stuck in your head. You probably, the first 3 or 4 times you're doing it, you're looking them up. After that, they're probably stuck in your head, and you've got to make sure they remain stuck in your head when we do the test. All right, there's some questions for you to do. Enjoy. Mr. Patch, over and out.